All right, so after we approximated areas under the curve, what we said was we recognized that something we would like to do is say from that we would like to shove as many rectangles as we could in here. In fact, if we let that number of them approach an infinite amount of rectangles, then we would get an exact value out of that. So we started with that same expression where we had something like f of a plus I times delta x from 1 to n. And we said we're going to let n get really big to like infinity. So following our example where we had f of x equaled x squared plus 1, then what we would get here is that now delta x is going to be 2 over n, and so that changes our expression to be, we've got this 2 over n, and then we have the sum from 1 to n of f of a is still 0. We were starting at 0, and we're going to 2. So plus I times delta x, but again, delta x is, so we'll say 2I over n. Remember that f of x equals x squared plus 1. So we can actually evaluate this thing. And when we do so, we get 2 over n, 2 over n, and we have the sum from 1 to n of 2I over n squared plus 1, which is 2 over n. We got the sum, and we have 4I squared over n squared plus 1. Now, here, the only things that are being summed are the i's, so we were able to take that n squared out, and we have something like 2 over n cubed. We've still got this sum here from 1 to n. Actually, I'll take that 4 out also, so we actually have 8 over n cubed. And I just have I squared plus 1. Now, I know we developed we were told what the sum of I squared was. The sum of I squared was n cubed over 3 plus n squared over 2 plus n over 3, I think, or 6. We'll check this on the computer. We'll make sure. So basically what we have then is we can just substitute that in for our summation here. Instead of the sum of I squared, we know what that is. It's this expression. The sum of 1 is just n. And so we had something like 8 over n cubed times n cubed over 3 plus n squared over 2 plus n over 3, and actually this is plus n. And we distributed and we simplified, and then we said, okay, like this guy would still have an n in the denominator. Well, we would get 8 over 3 plus 8 over 2n plus 8 over 3n squared plus 8 over n squared. And all of these guys, when we make n very large, they all go away. And so we would have something like 8/3. Now, this will tell me whether or not at least in part, whether I got this formula right, but probably not, because that term didn't matter anyway. All right, but that's what we did. We just kind of substituted these summations in and used the formulas either that we knew, or we could use the computer to find that and evaluate them at some value. Okay. This was obviously tedious, but we explored some rules that we found in these summation formulas to get something like our power rule, where we have now the definite integral from a to b of x to some power was equal to x to that one more power over n evaluated at a and b.